Monday's homework, question 1. It says the Metropolis Zoo recently celebrated the birth of two new baby pandas, Mochi and Kappa. We've actually seen this before, so it should look very familiar. We are just continuing to compare two linear functions. Question 1 says which panda was heavier when they were born. So I need to know the initial value so I can find the initial weight for Mochi, and I see that at 0 weeks his weight was 1 pound, so that's like a y-intercept, which is the initial value, so he was 1 pound. Then Kappa, I see I've got to be careful looking at the y-axis. They are counting by twos, so Kappa was initially 2 pounds when he was born. That's the y-intercept for Kappa. So which one was heavier? Kappa. Which one's growing faster? So they're talking about slope, rate of change. To find rate of change or slope from a table, you do changes in y divided by changes in x. So we've got plus 4, plus 4, plus 4, over plus 1, plus 1, plus 1. Slope is change in y divided by change in x, because this is xy. So it's 4 over 1. So Mochi's growing 4 pounds per week. Kappa, I'm trying to find slope from a table, so I want two good ordered pairs. I see I have the point 0, 2, and then I have another good point right here at 2, 8. So finding slope from 2 points, I know I'm doing y2 minus y1, so 8 minus 2 over x2 minus x1, 2 minus 0. That gives me 6 over 2, which is a rate of 3 pounds per week for Kappa. So Mochi is growing faster at 4 pounds per week. Which one will weigh more at 5 weeks? So it's going to be helpful. You could really just kind of continue the pattern from where they are. It's just another way of doing it, but really it will be helpful to actually write some equations. If I were to write an equation, a linear equation to model Mochi's growth, it would be y equals the rate of change is 4 pounds per week plus the initial weight of 1 pound. An equation for Kappa would be y equals 3 pounds per week plus the initial weight of 2 pounds. And if I want to know the weight at 5 weeks, and x is the number of weeks, I would plug 5 into each of them where x is and solve. So 4 times 5 is 20 plus 1, so Mochi is going to be 21 pounds. 3 times 5 is 15 plus 2, so that would be 17. So Kappa is going to be 17 pounds, so Mochi is going to weigh the most at 5 weeks. Question number 2. Two contestants on the Biggest Loser are Valerie and Oscar. Their weight loss progress is shown below. So Valerie is an equation, Oscar is in a table. Who weighed more at the beginning? So this is the y-intercept. So in this equation, even though it's w and t, this is like a y and an x. The number in front of x is the rate of change or the slope. So she's going down 2.5 pounds every week. The initial weight for Valerie is 235 pounds. For Oscar's weight, his rate of change here, if I wanted to find the slope, I'll find the changes in y over the changes in x. So this is down 4, then this is from 4 down 6, and this is down 2. This is over 2, over 3, and then this is over 1. So negative 4 over 2 is negative 2, negative 6 over 3 is negative 2, negative 2 over 1 is negative 2. So the rate for Oscar is going down 2. The initial weight is at 0 weeks. That's the y-intercept. So the initial weight for Oscar was 247. So it said who weighed more? Oscar. Who is losing weight faster? That's the rate of change. So I got just down 2 pounds a week versus 2.5. So Valerie. How much weight is Valerie losing per week? 2.5 pounds. How much weight is Oscar losing per week? 2 pounds. Okay, so I wouldn't say negative 2 because they're just, the negative is the losing part. Alright, Mr. Rich recently planted a crop of money trees in his garden. First tree was 5 inches tall when it was planted and grows 4 inches every month. So 5 is a y-intercept and 4 inches every month is the slope. If I wanted to write an equation to model the growth of the first tree, it would be y equals 4x plus 5. Y equals mx plus b. Okay, for measurements were taken for the second tree, tree B. So I have a rate of change here, change in y over change in x. This is going up from 3 to 12, that is plus 9. Then I've got from 12 to 16, that's 4.5. And then it continues 16 to 25.5. So that would be 9. So then this is up 2, up 1, up 2. When I reduce them all, 9 divided by 2 and 4.5 divided by 1 gives me a slope of 4.5. The initial value is going to be the height at the beginning, 0 months, so the y-intercept is 3. So the equation for tree B would actually be y equals 4.5x plus 3. And then the last one, tree C, starts out at 10 inches, so the y-intercept is 10. And then the rate of change, I can't really see very clearly, but they do provide us with some numbers. So I could use the point 0, 10 and pick any other of these good points. I have the point 217 here. They tell us that's landing on 217. And find my slope from 2 points. So y2 minus y1 is 17 minus 10 over x2 minus x1 is 2 minus 0. So 17 minus 10 is 7, 2 minus 0 is 2. So this tree is growing 3.5 or 3.5 inches a month. So the slope is 3.5, and the equation for tree C would be y equals 3.5x plus 10. So which one is growing the fastest? Which one has the highest slope, highest rate of change? So we got 4, 4.5, 3.5. That's going to be tree B. How tall was tree C when it was planted? So that's the y-intercept or initial value. That is going to be 10. Which tree is the tallest after 6 months? So using these equations, I'm going to plug in 6 for x for all of them. So I've got here 4 times 6 plus 5. So that's 24 plus 5. So 29 inches after 6 months. Tree B, I've got 4.5 times 6 plus 3. So 4.5 times 6 is 27, and 27 plus 3 is going to be 30 inches. And then we've got tree C, which is 3.5 times 6 plus 10. So 3.5 times 6 is 21, plus 10 will give us a height of 31 inches. So out of all three of them after 6 months, tree C is the highest, and it is 31 inches. Now if you were to guess, it would be kind of scary because it's 29, 30, and 31. They're all very close. It's better to be able to be mathematically accurate. All right, last question on homework, or last section. Tony is the best pizza delivery man in the city. He has been offered jobs by all the best pizza places. So he's got Bambino's, Little Squeezers, Pizza's Tent, and Papa Ron's. We want to know which company pays the best pay per shift. So we really just want to know the slopes or the rate of change for all 4 companies. Again, then we're going to want to look specifically at Little Squeezers' rate of change, and then we can answer this final question. So let's practice kind of writing equations for each piece. Bambino's pizza is $56 per shift and $2.50 in commission for each pizza. So $56 flat fee and $2.50 per pizza. That's like a rate of change or a slope. So if I wanted to write an equation for Bambino's here, it would be y equals 2.50x plus 56. Little Squeezers, so I need a slope and a y-intercept. So 48 to 54, that's plus 6. Then we've got plus 6 again, and then we've got plus 18 over plus 2, and then plus 6. So 6 divided by 2 and 18 divided by 6 all give us a rate of change of 3. The beginning salary here is for making no pizzas, he would get $48. So that's a y-intercept. So the equation for Little Squeezers would be y equals 3x plus 48. Pizza Tent already gives us an equation. It's $2.75 per pizza plus a $52 initial salary. And then Papa Ron's is on the graph. It's a little bit blurry, but it looks like that says 60, I believe. So we've got initial value, a y-intercept of 60, and then we need to find the slope. So I would use the points 0, 60, and I think that says 64, so 264. So y2 minus y1 is 64 minus 60 over x2 minus x1 is 2 minus 0. So that comes out to be 4 divided by 2, which is a rate of change of 2. So the equation for Papa Ron's is y equals 2x plus 60. So which company pays the best? Which one has the highest pay per shift? So pay per shift is actually the y-intercepts here, because that's not based upon the number of pizzas sold. That's just how much they make just for showing up. So we got 56, 48, 52, and 60. So the highest y-intercept, so per shift, is actually going to be Papa Ron's. How much does Little Squeezers pay per pizza? So Little Squeezers, the pay per pizza is actually the rate of change. So it's going to be $3 per pizza. And if Tony's going to deliver at least 20 pizzas every night, which company should he work for? So this is really why I wrote all 4 equations. So now I can take 20 and substitute it in for each one of these where the x is and find the exact pay per pizza. Okay, so Bambino's, 250 times 20 plus 56. So he would make $106 at Bambino's for 20 pizzas. Little Squeezers here would be 3 times 20 is 60 plus 48 would be $108. Pizza Tent, we got 2.75 times 20 would be 55 plus the $52 for just showing up, so that's $107. And then 2 times 20, which is 40, plus 60 is $100. So the highest pay for that many pizzas, not by much, is actually Little Squeezers. Okay, and that is all 4 homework questions.